So you have 15 minutes to answer parts A through F. And I'll just leave that right there. Okay, so based on your responses, we got some up and down in terms of confidence level here. So we're going to go through this, and then you will get a chance to ask any questions you have. And those questions may be related to the scoring or to how to do the problem. So you've got this particle that moves along the x-axis, so its time is given in seconds, and its position is given in meters. Those units are very important as we come through and we answer our questions. All right. Do note you are given this domain restriction out here that t is greater than or equal to 0. That will come into play, especially when we get to part D. Okay, so part A. Part A is worth 2 points. Find the displacement of the particle over the first 4 seconds. So displacement, just how much movement do we have and what direction is it? So I need to know my position at 4 seconds, so x of 4. I need to know my position on the number line when t is 0. Where did I start? And I want to subtract the values between those, or if you want to draw out your picture, right, that's just fine as well. And we've moved 4 meters to the right. Now, this is all worth 1 point. So having our work, having our answer, and including meters. Unfortunately, if you didn't include meters, you don't get that 1 point. Although you knew what you were doing and you want to make sure you're paying attention to units. So that's part A. An all or nothing. Now, part B is worth 2 points. So part B says at time t equals 0 is the particle moving to the right or to the left. And we've got to explain our answer. And so in this problem, the 2 points are from, first of all, correctly saying the particle is moving to the right. Now, I know the particle is moving to the right because I looked at the derivative of position. Now, I've called that velocity. Okay? And I calculated that derivative at 0, and it was greater than 0. It was a positive value. That tells me that position is increasing, therefore I'm moving to the right. So somewhere in my explanation, I have to talk about that the derivative is greater than 0. Now, little detail. If you talked about velocity is greater than 0 and you nowhere notated that velocity was the derivative, you won't get credit for the justification. Make sure somewhere in your work you have, and it could be dx dt is equal to v, that's just fine, but somewhere in our work we need to have noted velocity is the derivative. If you're going to use v for velocity, you could just use x prime of 0 is greater than 0, and that would be just fine. Right? But our 2 points are that we went to the right and that we have work to show, and we stated explicitly the derivative was greater than 0. Okay, it's positive. Part C is also 2 points. It's 2 very similar points. Part C says at time t is equal to 1 is the velocity of the particle increasing or decreasing, and to explain our answer. So one of those points is that the velocity is decreasing, that I've answered that question. And then I've answered it by doing the same thing. I've taken the velocity function and found its derivative. I called that acceleration. And that the acceleration, the velocity's derivative, is less than 0. So that tells me velocity is decreasing. So 2 points there in part C. Now, if you got parts A, B, and C perfectly correct, you've already gotten at least a 5 out of 9. So you're doing a really good job. Part D, find the values for t which the particle is moving to the left. Now, part D is worth 2 points. Somewhere in your work, you've got to have that you looked at where velocity was less than 0. Now, I don't have to have it twice, but somewhere you've got to have that you're looking for velocity being less than 0. Now, if up here in part B, you called the derivative of x prime, velocity, then it would be just fine to just have the expression for velocity and set it less than 0. Nothing at all wrong with that. Okay? But we've got to be looking at where the derivative of position velocity is less than 0. Now, as you were solving this, if you factored and you set each factor less than 0, this is mathematically incorrect. And so you're not going to get any credit because you've done something mathematically, right, that's incorrect. Not just you made a mistake, you added wrong or you subtracted wrong. You've done something conceptually wrong. If I multiply two negative values together, they aren't less than 0. Now, you could decide where your derivative velocity is less than 0 by drawing a graph of velocity, making sure you labeled that's a graph of velocity, or making a sign chart. Now, what you really want, if I have drawn this graph, it's actually an inaccurate graph. My graph needs to have an endpoint here at 0. And the same thing in my sign chart. I only have time values greater than or equal to 0. And so I do need those endpoints there at 0, whether I look at the graph or I look at the sign chart. Now, if in your sign chart you prefer to have multiple lines, t minus 3, t minus 1, and then t minus 3 times t minus 1, that's just fine. Right? Ultimately, I have to have the signs of the derivative. However you got to that, I've got to know where it's positive and it's negative. Right? And so our 2 points come from our interval, whether you wrote it as an inequality or an interval notation, doesn't matter, and that you dealt with that the derivative had to be less than 0. So that's part D. Part E is an all or nothing. Find the velocity of the particle when the acceleration is equal to 0. So you've got to set your acceleration equal to 0. So back in part C, you should have noted your acceleration was the derivative of velocity or the second derivative of position. That would be just fine. And you have to write equals 0. Don't just do 6t minus 12, t is equal to 2. You've got to have that equation to solve. And then we need to find the velocity when t is equal to 2. It is -3 meters per second. And without units, I don't get that 1 point at all for part E. Although I knew how to do everything without units, I don't get credit. So do want to make sure I pay attention there in part E to units. And then in part F, we're finding when the speed of the particle is increasing. So you need to have a sign chart for your derivative of position, velocity, your second derivative of position, acceleration. Now, you don't have to label it as both things, but you could label it as either one. Now, I redrew my velocity sign chart that I did up here in part B. In part D. You don't have to redraw it. If you did it graphically, you could look at the signs of velocity and acceleration based on graphs of that quadratic for the first derivative and that line for the second derivative. That would be just fine. But I have to look at signs for both. And so the speed of the particle is increasing from 1 to 2, union with 3 to infinity. And I've got to have a reason why, or I don't get the 1 point in part F. Because I looked at where velocity and acceleration, the first derivative and second derivative of position, have the same signs. Now, I want you to give yourself a score out of 9. And while when we deal with a free response question, we are looking to average at least a 5 out of 9. I'll tell you, if this is your AP exam, this would be a problem you're really looking for 7 out of 9 or better. And the reason is I'm going to call this an easy problem. Be careful with that word easy. That doesn't mean you might not have had a little bit of trouble with this free response, but this is easy in the sense that it's a straightforward free response question. There's nothing overly tricky about this problem. Okay? This is identical to things you've worked with in class. And when I say easy, that really means easy by the time you get to taking your AP exam. Not necessarily today. But you're going to have free response questions that are worded or look or do something different than what we've done in class. This isn't it. So if I get a free response question that's straightforward like this, I want to be on the higher end of those 9 points in case I have a problem I struggle a little bit more with. Okay? Now, we're going to go through part by part, and if you've got questions on the scoring or questions on how to do the problem, please speak. So let's start with part A. Are there any questions in how to find the displacement of the particle or in the scoring? Just part A. We'll get to part D in a minute. Let's go one part at a time. Okay. Part B. Where we're figuring out if the particle is moving to the right or the left. Is my position increasing or decreasing? That's what this question is asking. Are there questions in finding that answer, your work, or in scoring? Yes, you have to write that velocity is the derivative of position. You can't just call this v of t because it looks like magically 3t squared minus 12t plus 9 just showed up. You've got to notate that this is the derivative. Other questions there in part B? Okay, part C, the scoring was similar to part B, but we're looking where the velocity is increasing, so we're wanting to look at the derivative of velocity. Any questions there in part C? Okay, so we had a question in part D, and that question, I think, was if the inequality has to be a strict inequality. And that answer is yes. If you used brackets or you used equal to, the answer part is incorrect. Now, you might get the justification part, but the answer is incorrect. And the reason for that is when t is equal to 1, velocity is equal to 0. When t is equal to 3, velocity is equal to 0. Our particle's not moving to the left. Our particle is at rest when t is equal to 1, when t is equal to 3. And so I have to use parentheses. I have to use strictly greater than inequalities there. Greater than, less than. Are there other questions in part D? Well, it's not equal because when t is equal to 1, velocity would be equal to 0. If you plug a 1 in here for t, 0 times t minus 3 is going to equal 0. And if my velocity is equal to 0, that's no change in my position. The slope is 0. Well, if there's no change in my position, that means my particle's at rest. It isn't moving to the left. It's standing still. It's standing still because it's actually changing directions here, right? When we were less than 1, we were moving to the right. When we were greater than 1, from 1 to 3, we're moving to the left. At 1, we're changing directions. And the same thing at 3. We're changing directions here. All right, part E. Are there questions in how to do part E? The scoring is pretty straightforward. Either you got -3 meters per second or you didn't. Any questions there in part E? All right, and any questions in part F? you do have to have an explanation with those values. Okay, and you could write that in inequality notation. You don't have to use intervals. It would be just fine. T is greater than 1, less than 2, or T is greater than 3. That would be just fine. Any questions there in part F? You won't get credit. And you won't, because you have to justify talking about the signs of velocity and acceleration. Right? Now, I'll be honest, I like Emily's suggestion, and I probably, at least in my head, dealt with the graph of the absolute value of V of t. But I can't do the problem with a picture. I can check myself and see, did I do this right? But because I'm going to have to talk about the signs, I can't justify based on a graph. And the same thing is true back here in part D. I can draw the graph of velocity, but a graph cannot be my explanation or justification. It can be part of my work to get the answer, but I have to talk about those vectors having the same signs. That's a really important question. All right, so it gives you a feel for where you are in terms of our application of derivatives that we've done so far with position, velocity, and acceleration. You have a little of almost everything we dealt with there in that free response question. Now, the only thing that would have made this, and I just didn't do it because it's on my screen, would have made this look more like an actual free response question is, in a free response question, you're going to have a little horizontal line below the problem. And the reason for that is because when you do this, anything you write up here above the line would not be graded. And so actually, if you had answered your questions right up here, the AP reader is not going to look at them. Okay? But it does give you a place you can do scratch work nobody's ever going to look at. And so when you do a free response question, you will see that little horizontal line. All right, if you will grab for me your notes from yesterday where we dealt with our trig derivatives, and you had to finish up last night deriving the derivative of our last 3 trig functions. You already had the answer. You just had to be able to go through, and actually all 3 of them are using our quotient rule. So the derivative of secant, before I get so excited to take the derivative, I can rewrite secant as 1 divided by cosine. And then we have the bottom times the derivative of the top minus the top times the derivative of the bottom. The derivative of 1 is 0. The derivative of cosine is negative sine. And so you have sine x divided by cosine squared, or the derivative of secant is secant tangent. And that's where we left off yesterday. So you had to find the derivative of cosecant. So 1 divided by sine. Again, it is our quotient rule. The bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. The derivative of 1 is 0, that constant. The derivative of sine is cosine. And so you have negative cosine x divided by sine squared x, or negative cosecant x cotangent x. Questions in cosecant's derivative? All right, the derivative of tangent. Tangent we can rewrite as sine divided by cosine. And again, the quotient rule. The bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. The derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine x. And so I get cosine squared plus sine squared in that numerator, or just 1. So 1 divided by cosine squared is secant squared. The derivative of tangent there is secant squared. Questions there with the derivative of tangent? And then your last one, you actually could do in 2 different ways. Your derivative of cotangent, you could rewrite cotangent as cosine divided by sine, or 1 divided by tangent. I think the simplification is easier in cosine divided by sine, but both work. Both are just using our quotient rule. So ho-de hi minus hi-de ho over ho-ho. The derivative of cosine is negative sine. The derivative of sine is cosine. And we actually get negative 1 in the numerator. divided by sine squared, or negative cosecant squared of x. Now, you actually had all of those answers from what we talked about yesterday, right? And we looked at yesterday all of the co-functions, right? This relationship that I really only need to know 3 of these derivative shortcut rules: the derivative of sine, the derivative of tangent, and the derivative of secant, right? Because those co-functions, right, their derivatives are opposite co-functions. Secant and cosecant are co-functions, and the derivative of cosecant is the opposite, negative, of the cofunction. Right? The cofunction with secant is cosecant. The cofunction with tangent is cotangent. Now, it'll probably be Tuesday, but Monday and Tuesday, we're going to talk about the chain rule, and we're going to come back. We're going to prove, why does this opposite cofunction relationship happen when we have our trig functions? Now, I want to see how we're doing using our trig derivatives. And I want to preview for you, before we look in your notes at x cubed cosine of x, where it has some horizontal tangent lines, why it's going to be really, really important for you to have these trig derivatives memorized. When we come back from Christmas break, we're going to deal with problems like this. The derivative of some function y with respect to x is secant x tangent x. And you're going to have to figure out, what's y? Not, let me take a derivative, but a derivative has been taken. What did I take the derivative of? Somebody tell me, what do you take the derivative of and get secant tangent? This is the derivative of secant, but actually, it's not just secant of x. That's correct, but it could be secant of x plus 1. Because the derivative of 1 is 0. Or it could be secant of x plus 2. Or secant of x minus a half. In fact, it could be secant of x plus any constant, and I'll just call that c. This will be what we work on after Christmas break. So we have to know these derivative rules really, really, really well. All right. I want to give you a couple minutes to try. If f of x is x cubed cosine of x, where's the tangent line horizontal? So see if you can find, where would the tangent line for this curve be horizontal? All right, so let's check and see how you did. Now, this problem is a really good illustration of really what most of our calculus as we continue to move forward is going to look like, because there are multiple skills going on in this problem. First of all, I've got to recognize some calculus skills. We're talking here about a tangent line being horizontal. That means the slope of the tangent line is going to equal 0. And that means I need to know that the slope of that tangent line, I'm going to find a derivative. I need to know derivative means slope of the tangent line. So I've got to be able to calculate f prime. Now in this problem, we have x cubed times the cosine of x. So to find f prime, we're going to have to use, I don't have a choice, I'm going to have to use the product rule. I can't rewrite x cubed times cosine of x to make this any easier. So the first times the derivative of the second plus the second times the derivative of the first. Now, by itself, neither of those individual derivatives should be terribly bad for us to calculate. We have the derivative of cosine, which we looked at yesterday and you used in homework last night. It is negative sine of x. And the derivative of x cubed is just our power rule. The derivative of x cubed is 3x squared. So we have to be able to take the derivative. And then we need to be able to use some algebra skills. We want the derivative to equal 0, and we need to write that that's equal to 0. And we need to have the algebra skills to actually solve this equation. We can factor. an x squared or a negative x squared. Either one would be just fine. And we know if we've got two things multiplied together and their product is equal to 0, we can set them both equal to 0 and solve. So either x is 0 or negative x sine x plus 3 cosine x is equal to 0. And I actually think this second piece might have the most important skill in this entire problem. And that skill is you need it as you work to recognize you need this little tool. You need a calculator. And you need to know when you need a calculator to solve. You solved lots of trig equations without a calculator, but not trig equations that also have an x in them. So we need our calculator. I just went ahead and graphed my derivative of x cubed cosine x. And I want to find these little x-intercepts. Now I've graphed here from negative a half to 2 pi plus a half. And this last x-intercept out here on the end, I will need to know what that is to know if it fits between 0 and 2 pi. But I'm just going to calculate my zeros. I'll illustrate one of those. I'm to the left of an x-intercept. Then I'll move till I'm to the right of an x-intercept. And guess, that x-intercept is more than 2 pi. While it is a solution where we have a horizontal tangent line, our derivative equal to 0, it isn't going to be in our interval from 0 to 2 pi. We should have gotten that x was 1.192 or 3.38. But I need a calculator to do that. And I do want to round there to 3 decimal places. So putting together algebra skills, some trig skills, and our calculating derivative skills. Okay? So tonight your homework is in Math Excel, working some more with our trig derivatives. For those of you that are face-to-face, you should have also gotten a copy of notes that we will deal with on Monday. For those of you that are at home, you will be able to get those on Monday. All right, guys, have a great weekend. So that second x-intercept I miswrote over here, it should be 3.809. I accidentally added an extra 3 in there. So we should have 3.809 for that second piece. So just want to make sure we clear that up.